Welcome back to Soma and Sage. Today, we are conducting a deep dive into a pervasive issue affecting cognitive performance, brain fog. If you have ever walked into a room and experienced a sudden, complete failure of working memory, forgetting exactly why you are there, you are not alone. Perhaps you struggle with anemia, the frustrating inability to retrieve the correct words during a conversation, or you feel a generalized psychomotor slowing, where your processing speed feels significantly delayed. While brain fog is not a specific medical diagnosis in the Diagnostic and Statistical Manual, it is a very real, clinically recognized constellation of symptoms indicating that your neural networks are struggling to maintain homeostasis. In this lecture, we will deconstruct the neurobiology of why this happens, analyze the systemic causes, and identify the threshold for seeking clinical intervention. To understand brain fog, we must look at the prefrontal cortex. This is the area of the brain responsible for executive functions, planning, focusing attention, and regulating emotions. When you experience fog, you are essentially experiencing a temporary downregulation of executive function. Neurologically, this can be described as a decrease in synaptic efficiency. Your neurons communicate via electrical and chemical signals. In a foggy state, the transmission of these signals, specifically along the pathways connecting the prefrontal cortex to other brain regions, becomes noisy or sluggish. It is a disruption in the signal-to-noise ratio within your neural circuitry. How does this manifest in daily life? It is rarely a singular symptom. First, there is the impairment of working memory. Unlike long-term memory, working memory is your brain's scratchpad for holding immediate information. When this is compromised, you cannot hold a thought long enough to execute an action. Second, there is attentional deficit. You may find it impossible to filter out distractions. This is a failure of inhibitory control, meaning your brain cannot suppress irrelevant sensory data, leading to mental exhaustion. Third is cognitive fatigue. This differs from physical tiredness. It is a state where mental tasks require a disproportionately high amount of metabolic energy, leaving you feeling drained after simple interactions. Now, let us analyze the causes. We begin with lifestyle factors, which are often the primary drivers of this dysregulation. The most critical factor is sleep architecture. It is not just about hours slept. It is about the quality of the glymphatic system's activity. The glymphatic system is the brain's waste clearance pathway. During deep, slow-wave sleep, glial cells shrink to allow cerebrospinal fluid to wash away neurotoxins and metabolic waste products, such as beta-amyloid and tau proteins. If you do not achieve deep sleep, these toxins accumulate, literally clogging neural pathways and resulting in morning fogginess. Next is chronic stress and the HPA axis. When you are stressed, your hypothalamic pituitary adrenal axis releases cortisol. While useful in short bursts, chronic exposure to high cortisol levels is neurotoxic. It can inhibit neurogenesis, the creation of new neurons, in the hippocampus, the brain's memory center. Essentially, stress puts your brain in survival mode, prioritizing the amygdala, fear center, over the prefrontal cortex, logic center. We must also consider nutritional biochemistry. The brain is an energy-expensive organ, consuming about 20% of your body's glucose. Fluctuations in blood sugar, specifically reactive hypoglycemia, can starve the brain of fuel. Furthermore, deficiencies in B-complex vitamins, magnesium, and omega-3 fatty acids impair the myelin sheath, the protective coating around nerve fibers that ensures fast signal transmission. Even mild dehydration disrupts the electrolyte balance required for the action potentials that allow neurons to fire. Beyond lifestyle, there are systemic medical causes. Systemic inflammation is a major culprit. When the body fights an infection or manages an autoimmune condition, it releases signaling proteins called cytokines. These inflammatory cytokines can cross the blood-brain barrier and alter neurotransmitter metabolism, reducing the availability of dopamine and serotonin. This is often why you feel mentally slow when you have the flu or a chronic inflammatory condition. Hormonal endocrine disruptions play a significant role. Estrogen, progesterone, and testosterone are neuroprotective. A sudden drop or imbalance in these hormones, such as during menopause or andropause, can lead to significant cognitive blunting. Similarly, hypothyroidism slows down the basal metabolic rate, affecting every cell in the body, including neurons. We also see this in cases of hypoxia. Conditions like anemia or sleep apnea reduce the oxygen saturation in the blood. Without adequate oxygen, the mitochondria in your brain cells cannot produce enough ATP energy to function optimally. So, when does a bad day become a clinical concern? You should consult a physician if the brain fog is persistent, worsening over time, or accompanied by other neurological red flags such as numbness, tingling, loss of balance, or severe headaches. It is vital to rule out underlying pathologies. Conclusion: think of brain fog as a biofeedback mechanism. It is your brain's warning light. It is saying, something is out of balance. The system requires a reset. Whether the root cause is sleep deprivation, nutritional deficits, or systemic inflammation, acknowledging the symptom is the first step toward restoring your cognitive acuity. Thank you for watching Soma and Sage. We hope this analysis illuminates what is happening inside your mind. If you found this helpful, please like, subscribe, and share to help others find clarity.